Alright, so today we're going to talk about the quadratic formula. So remember, up until this point, we've talked about solving quadratics by graphing and also by factoring. And the reason why we had to get factoring was because we saw that we couldn't use graphing every single time. And there are also going to be some times where we cannot factor as well. And so we need other options. And we actually have two more options. One of them is completing the square, which we're going to go ahead and do with our next set of notes. But then the other way is the quadratic formula. And you'll see this come up quite a bit in your upper level math classes as well as a lot of your science classes. And we'll be using it quite a bit in our physics problems throughout the year this year as well. So the biggest thing that we need to do to start off with is find out what our quadratic formula is. So our quadratic formula starts with x equals. Now remember that we're solving for x, and so that's why we have our x equals. And there are a couple of little like songs and jingles or rhymes that might help you with this. And I might play some for you in class the next time that I have you in class. But for right now, we're just going to stick to the actual formula itself. So it is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, these a's, b's, and c's are coming from our quadratic standard form. So ax squared plus bx plus c. So we're using those coefficients to plug into our formula. So this says to solve x squared minus 10x equals 11 by using the quadratic formula. And it's really important that if a question, either in your homework or on a quiz for me, gives you a specific method that it's wanting you to use, you need to use that method. Now, if it just says solve and it doesn't specify, then use whichever method you like the most. But if it gives you a specific method, you have to use that method. Especially on a quiz or test, if I'm grading for a specific method and you don't use that method, then I have to take off points for that. So just make sure that we use whatever method that they tell us to. So remember that our first step when we're looking at a quadratic equation is that we need it to be set equal to 0. So our first step is going to be to subtract 11 from both sides. And then we want to identify our coefficients. So notice here, our a is going to be 1, our b is going to be negative 10, and our c is going to be negative 11. So notice that our coefficients include the sign, so if it's positive or it's negative, for our x squared, because there's not a number there. Remember that is an understood 1. And I also noticed that these do not include our x's. We're not going to be plugging in x's, and that's really important because we're trying to solve for x, so we can't plug in x's into our formula. So let's write out that formula again, so we just kind of practice it and get better at memorizing it, because we will need to memorize it. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So our first step is just going to be to plug everything in. So I have negative 10, but it's not just negative 10. It's a negative 10 plus or minus the square root of negative 10 squared minus 4 times 1 times negative 11 all over 2 times. And that's right there is going to be an important step and one that I would give you credit for. So remember, we've talked about just because you can't do the whole thing does not mean that you can't do part of it. So we need to at least be able to plug everything in, find my A, B, and C, and plug it all in to the right spot. And from there, we just need to simplify. So a negative is going to be a positive. I have 10 squared, which is going to be 100. So I have minus a negative, which is going to turn it into addition. And then we have 4 times 1, which is 4 times 11, which is going to give us 44. And then 2 times 1 is just 2. So now we have 10 plus or minus the square root of 144 divided by 2. Well, the square root of 144 is 12. All right, now from here, what's really important is that we notice that we have a plus sign and we have a minus sign, which actually means that we're going to get 2 answers. So from here, I'm going to go ahead and I'm going to separate them out. I'm going to do 10 plus 12 divided by 2, or 10 minus 12 divided by 2. So 10 plus 12 is going to give us 22 divided by 2. 10 minus 12 is going to give us negative 2 divided by 2. So we're going to get a positive 11 or a negative 1. And those would be my 2 answers. So in this case, because we got whole numbers, we could have actually factored this, or we could have graphed it, and we would have been able to get the same answers. But they asked us to use the quadratic formula, and it was good practice for us to get nice whole number answers. Now, we won't always be as lucky, but the nice thing about the quadratic formula is it will work no matter what our answers are. So let's look at the next one. We have x squared plus 8x plus 16. So again, we want to look at our a's, b's, and c's. So a equals 1, b equals a positive 8 this time, and c equals 16. So again, writing out that formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, my first step and the important step is going to be that I just plug in my a, b, and c value. So this time the negative is going to stick. So we just have negative 8. And then we have our plus or minus. Then we have the square root. This time we're going to have 64 minus 4 times 1 gives us 4. 4 times 16, 4 times 6 gives us 24. 4 times 1 gives us 4, plus that 2 gives us 64 divided by 2. Well, hopefully we've noticed that underneath my radical, we're going to get 0. And the square root of 0 is 0, so we get negative 8 plus or minus 0, so we get negative 4. So in this case, we only get one answer. And hopefully we remember that that means that our vertex is going to have to be on our x-axis, which is why we only get one solution. Alright, so this time, again, using the quadratic formula. So we have a equals 2 this time, b equals 6, and c equals negative 7. So our a value isn't 1 this time, but that's okay. The quadratic formula is still going to work the same way. So again, plugging in, we get -6 plus or minus the square root of 6 squared minus 4 times 2 times -7 all over 2 times 2. So again, we want to try and simplify everything as best as we can. So -6 is just going to be -6 plus or minus the square root of 36 minus 4 times 2 gives us 8. 8 times 7 is going to give us 56. Notice that we have a subtraction sign and a negative, so that's going to become positive. So now underneath our radical, we have 56 plus 36 which is going to give us the square root of 92. So I got 92. 92 is not a perfect square. So now would be a good time for me to go back and check my work, make sure I didn't mess up anywhere. I have A is 2, B is 6, C is -7, x equals -b plus or minus the square root of b squared minus 4ac. So I have -6 plus or minus 6 squared minus 4 times 2 times -7. So 6 squared gives me 36. 4 times 2 is 8. 8 times 7 is 56. And I get a positive 92. So that tells me that it's not my work. My work is not incorrect. But that's always a good thing to go check, which is why it's important that our steps are clear and concise. But what we do want to try and do now is to break down that 92 by simplifying our radical. So hopefully we remember that we can make a factored tree. So I know that 92 is even, so 2 is going to go into that 46 times. And then 46 is also even, so I know that 46, 2 goes into it 23 times. Well, now looking at this, 23 is a prime number, so it's not going to have any factors besides 1 in itself. But because we have a square root, we're looking for groups of 2. So I know that I could rewrite 92 as 2 squared times 23. And the reason why that's important is because if we have the square root of 92, remember that we can rewrite this as 2 squared times 23. And as long as this is multiplication, we can break apart these two things. And so then our 2, the squared is going to reduce with the square root. So we would just have 2, and then our 23 is left underneath the radical. So since we know that the square root of 92 can be simplified, we're going to rewrite that. So plus or minus 2 square roots of 23 divided by 4. Now, our last step is going to be, hopefully we notice that all of my numbers, so 6, 2, and 4, can be reduced by 2. So as long as we can divide everything by a common factor, we're allowed to reduce. So I'm going to divide everything by 2. And when I say everything, I just mean the things that are being multiplied. So I don't have to divide the 23, just the 2. So our final answer is going to be -3 plus or minus the square root of 23 divided by 2. So notice that we do have two answers because we have a plus or a minus. Also notice that the square root of 2 is going to be an irrational number. It's going to be a decimal that goes on forever. So to try and graph this would not be fun. It's going to be in between two whole numbers. And then also to try and factor this would also not be very fun. So if I were to do 2 times negative 7, we get negative 14. And there are not two numbers that multiply together to give us negative 14 that add together to give us negative 6. So we can't factor it either. And that's where the quadratic method comes into play. Now, a lot of us are used to writing things as decimals or approximating, and most of the time, I don't want us to do that. Unless it says approximate this answer or give a decimal to the nearest hundredth or thousandth, this is how I want us to leave our answers. I want us to leave our answers exact, which means leaving it as the square root of 23. I don't want us to try and round and find a decimal approximation. All right, so we've looked at a couple of examples now. So our discriminant is going to be that stuff, that thing that's underneath our radical. So remember that our radical is the square root of b squared minus 4ac. And that part by itself is called our discriminant. And it's important because it tells us a couple of different things. So let me zoom in here. It's a little blurry, but we should still get it. So if b squared minus 4ac is greater than 0 and it is a perfect square, we will have two real rational roots, which means that we can write them as a fraction or a whole number. So like our first one, we had positive 11 and 1. Those would be rational roots. And our graph means that we're going to go through it twice on our x-axis. Now, if b squared minus 4ac is greater than 0, but it's not a perfect square. So like our last example that we did, where we got the square root of 92, we're still going to have two real roots, but this time they're going to be irrational. So we'll still have the graph that looks the same way. It's still going to cross our x-axis 2 times. Just those two numbers aren't going to be at nice, pretty numbers. They're going to be in between two integers, which is fine. I still have two real roots. They're just irrational. The next case is if b squared minus 4ac equals 0, we will have one real rational root. So that's like the example when we got 0 underneath our radical. That means that our vertex is located on our x-axis, so we're only going to have one root. And then our last kind, which we haven't gone over yet, but we'll go over in just a second, is if b squared minus 4ac is less than 0. We'll still have two roots, but they will be complex roots. So our graph would look something like this. So notice up until now, we've said no solution, or doesn't work, or we can't do it, any of those things, which is not technically true. We don't have any real roots. So we don't cross our x-axis. So we don't have any real numbers, but we still actually have two answers. They just happen to be imaginary or complex numbers, which is going to be important for us. So many times we want to try and use that discriminant to help us decide what types of answers we're going to have. So even before we start solving, sometimes we want to know the type of answers that we're going to get. So this says find the value of discriminant for each quadratic equation, then describe the number and type of roots for the equation. So notice that it doesn't even ask us to solve it altogether. So we don't need to solve it. The only thing that it asks us to do is to find that discriminant. So again, we have a equals 7, b equals negative 11, and c equals 5. On our second one, we have a equals 1, b equals 22, and c equals 121. So for part A, so remember that our discriminant is going to be that stuff underneath the radical. So b squared minus 4ac. So we want to plug in. So we would have 7 squared minus 4 times, negative 11 squared minus 4 times 7 times 5. So negative 11 squared is going to give us 121 minus 4 times 5 would give us 20, and then 20 times 7 would give us 140. So notice that when we do our subtraction, we are going to end up with a negative number, and we'll specifically end up with negative 19, which means that we're still going to have two solutions. They're just going to be complex roots. All right, so part B, we want to do the same thing. B squared minus 4AC. So B this time is 22. So 22 squared minus 4 times 1 times 121. So 22 squared gives us 484. 4 times 1 gives us 4. So 4 times 121 also gives us 484. So this gives us 0. So this means that we would have one real rational root. And when it's talking about us the number, obviously that's the 2 or the 1. The type is going to be either, like I said, the complex, or in this case, we have real rational.